Hello, the listener. This is M. Suleiman Enterprise, and in this lesson, we will learn about sequence starters from statement number 8. Right, from the statement, we start by saying when the start button is activated, motor 1 must start rotating. Right, so when we press the start button, motor 1 must rotate. After 10 seconds, motor 2 can be started by activating the same start button. Right. So firstly, we press the start button, motor 1 start to get energized. After 10 seconds, we must press the same start button that has energized motor 1 to activate the coil of motor 2, or to activate motor 2, right? And they say motor 1 must keep on running. So we will use the same start button to activate motor 1 and motor 2, right? And it says 10 seconds after motor 2 has started rotating, both motors, motor 1 and motor 2, must stop rotating automatically. So motor 1 will start rotating. After 10 seconds, we'll press the same start button again, in which it will energize motor 2. And then after 10 seconds, both motors will stop rotating. Right. Okay. We drew a compulsory scratch for all the sequence starters in the control circuit. So we'll start from the first statement when they say when the start button is activated, motor 1 must start rotating. So we will draw the start button. Right, this is our start button. So they say the start button must activate motor 1, right? But after 10 seconds, motor 2 can be started by activating the same start button. So this start button must rotate the coil of motor 1, and after 10 seconds, we must press it again to rotate the connection of motor 2. This simply means this start button, the wire after the start button must split the connection of motor 1 and the connection of motor 2 with the contacts of delay on timer, because of, they say, after 10 seconds, motor 2 can be started by activating the start button, right? So which means it will be the contacts of delay on timer. So the closed position side will be from the connection of motor 1, and the open side will be the connection of motor 2. Right, so when I press the start button, current will flow down and flows here to the closed contact, right, in which it must energize the coil of motor 1. Must energize the coil of motor 1, A1, A2, right, and all the way to our live 3 or our neutral. But we used 1M circuit breaker, which means it's our live 3. Right. So when the coil is energized, it must have its retainer. So it will have its retainer of motor 1 that will be connected all the way to retain the connection of motor 1. So when we press the start button, this will be on and this will be closed, so our current will flow this way after we have let go of the start button, right? So they said so we are done with sentence number 1. Sentence number 2 says after 10 seconds, motor 2 can be started by activating the same start button, right? So after 10 seconds, this contact will be triggered, but it will be triggered with the delay on timer, right? Yes, with the delay on timer. So the delay on timer will get the live current after the retainer of motor 1, right? So this is after the retainer of motor 1 with a live current in which it will supply the delay on timer. A1, A2. This is T1 for delay on timer, right? So it will energize delay on timer. So which means this auxiliary contacts will be for T1 for delay on timer. So after 10 seconds, it will trigger its contacts. Here it will be open and here it will be closed. And the closed part will be for, and this side will be for the connection of motor 2. So this will be the connection of motor 2. Right, connection of motor 2. So the connection of motor 2, the coil of motor 2, when it's energized, it must affect its retainer. So the retainer will be looped before the start button, because this start button uses the connection of motor 1 and the connection of motor 2. That's why we'll bridge it the same as the retainer of motor 1. Right. So we will press here to create close contact. Current will flow and energize coil of motor 1. Retainer will be closed, and also it will energize a coil of delay on timer. After 10 seconds, here it will be open, here it will be closed, but this one will still be energized through the retainer. And then that's when it allows us to press the start button again, which is here it has created close contact, and then it will energize coil of motor 2 and affect its retainer to be closed, which means after we let go of the start button again, the coil of motor 2 will keep on running through the retainer, right? So, and they said motor 1 must keep on running. Motor 1 will keep on running, right? And they said 10 seconds after motor 2 has started rotating, both motors, motor 1 and motor 2, must stop rotating automatically, right? So after the coil of motor 2 is energized, after 10 seconds, both coils must be de-energized, right? In which means no, both coils must be de-energized, in which means they must be off, right? So they must delay to be off after 10 seconds, in which means we will need the coil of delay off timer, coil of delay off timer, A1, A2. So the reason why we have inserted a normally closed contact before the delay on timer, which would be T2, is because of the delay on timer to start counting. It must have a contact that cuts its live current, in which it will affect the delay on timer to start counting, right? So this contact must be the contact of motor 2, because of the coil of delay of timer must start counting after the coil of motor 2 is energized. So when the coil of motor 2 is energized, it will affect this contact to be open, so that it will affect the delay of timer to be off, so that it can start counting and affect its contact, right? So since the delay of timer will get the live current after the retainer of motor 1 is closed, because of the retainer of motor 1 will be closed, and which means also our live current will energize the delay on timer, right? So the contact of delay on timer can be the one that helps the coil of motor 1 to get live current, right? Because of the time the delay of timer it gets energized, it will affect its contact same time, right? So we will insert it here, so that when it gets energized, it will affect its contact to be close same time and energize motor 1, right? So that it can energize motor 1. Right. So since this contact of delay on timer will help the coil of motor 1 to be energized. After 10 seconds, when the delay of timer is de-energized, it will affect this contact to be open again, in which means it will affect the coil of motor 1 to be off. And when the coil of motor 1 is off, it must also affect the coil of motor 2 to be off, because of after 10 seconds both motors must be off. So when this coil of motor 1 is off after 10 seconds, in which it will be affected by the delay of timer contact, this coil of motor 1 will help the coil of motor 2 to also be off after 10 seconds, right? Which means the coil of motor 2 will start with a normally open contact, so that when the coil of motor 1 is energized, it will become closed. After 10 seconds, that's where it will allow us to press the start button again. Current will flow here and energize coil of motor 2, and in which it will affect it retainer, which means right now our live current will flow all the way to coil of motor 2, right? So this is our sketch. Now let's do the operation together to confirm if it's right. Right, remember, when we press the start button, motor 1 must be energized. After 10 seconds, it must allow us to press the start button again, that we have used to energize the coil of motor 1, to also energize the coil of motor 2. So when we press this start button again, motor 2 will be energized. And then after 10 seconds, both motors will be off. So let's confirm it with the operation. We press the start button. Okay, firstly, let's switch on our 1M circuit breakers. Which is live 1, live 3, and then the outputs of the circuit breaker will be connected to the voltmeter, in which means it will give us the reading voltage of 400 volts to show that we have used a 3-phase supply voltage. Right, so our live current will continue from this side, but let's start with live 3 because of is the easiest one. The output of 1M circuit breaker from live 3 will be connected to the voltmeter, and also all the A2s of the coils, or coil of delay of timer, delay on timer, motor 2 and motor 1. From their A2s, that's where we will connect live 3, right? So even here it will be A1, A2, right? So our live current will flow down to overload relay 1, close contact, current will flow. Overload relay 2, close contact, current will flow. Emergency stop button, close contact, current will flow. stop button, close contact current will flow and be trapped before the start button, and also be trapped before the retainer of motor 1, and also be trapped before the retainer of motor 2, right? So since well our live current is stuck before the start button, it allows us to press the start button so that the current can flow all the way down, right? So we press the start button, it creates close contact, current flows down and energizes energizes the coil of motor 1, in which it will be on, and when it's on it will affect all its contacts. The retainer of motor 1 will be closed, the normally open contact of motor 1 will be closed, right? And let's check what has happened after the contacts of motor 1 has been triggered. So from the retainer of motor 1, live current will flow all the way to energize the coil of delay on timer, in which means it must start to count. But before it counts, we must also check where did the live current flow to, right? So it has also flowed to the close contact of motor 2, which means current will flow and all the way to the A1 of delay of timer, in which means it will also have A2. So the delay on timer will also be on, even the delay on timer will be on, right? So when the delay of timer is on, it will affect each contact same time. Here it will be closed, here it will be closed, right? And when it's closed, right now our delay on timer can start to count, right? So after 10 seconds, the delay on timer will affect its contacts. From where it is open, from where it is closed, it will become open, and then from where it is open, it will become closed, right? But let's check if this contact of delay on timer, if it has affected motor 1 to stop running. So from motor 1, coil of motor 1 will keep on running through the retainer and the normally closed contact of delay of timer, in which means it will flow all the way to A1, and A2 will also have live 3, which means coil of motor 1 is still running, right? So we are good. So this is after 10 seconds, right? So we let go of our start button, it creates open contact again, right? So this is the process after the 10 seconds of delay on timer. So we press the start button again, which means right now current flow all the way down to the close contact, right? So after we press the start button, current will flow down all the way to the close contact of delay on timer. Will flow this side and all the way to A1 of coil of motor 2, and from A2 to also have live 3, right? Which means right now coil of motor 2 will be energized, and when it's energized, it will affect all its contacts. The retainer of motor 2 will be closed, and then the close contact of motor 2 will be open. And when the close contact of motor 2 is now open, that's when it will de-energize the coil of delay of timer. It will be off, and when the coil of delay of timer it is off, that's when it will start to count to 10 seconds. Then after 10 seconds, that's when it will trigger its contacts. So this is the contact of delay of timer, it is closed. So right now it will be open, And when it's open, it has affected the live current from the coil of motor 1 to be cut. So which means right now coil of motor 1 will not get the live current, but only A2, in which means it will be off. And when it's off, it will affect these contacts, which is the retainer of motor 1. It will be open, and also the normally closed contact of motor 1, it will be open. And when the normally open contact of motor 1 is open, which means coil of motor 2 will not get the live current from live 1, because it was running through the retainer and also the close contact of motor 1. But since well right now the contact of motor 1 it is open, it simply means coil of motor 2 will not get the live current from live 1, because of the start button will be open after we have let it go. Always remember that, right? So coil of motor 2 will also be off, and when it's off, it will affect this contact. The retainer of motor 2 will be open, and also the contact of motor 2 will go back to be closed. It will no longer be open, but will be closed. Now the process went back to its original form before we made the process. So that is it about sequence starters from statement number 8. So you must be very careful about statement number 8, because of in this lesson we have experienced something new that we didn't do in the past sequence starters, right? So this is the last operation of sequence starters by using the same start button to operate the two motors. So thank you for watching this video. Catch you in the next lesson. Bye.